Three waters, the fundamentals. We're going to look at four things in this presentation. Firstly, a stormwater drainage network. Secondly, a little sewer network. Thirdly, the rising main that we're going to use to empty the sewer network. And finally, a water supply reticulation system. Hello, my name's Tony Ingold. I run Extra Dimension Solutions. We're the distributor for 12D model in New South Wales, the ACT and South Australia. The three waters that 12D talks about are stormwater drainage, sewer and water supply. This is the layout of a little stormwater drainage network. We overlay the sewer on top, and then here's our water supply added in as well. I'm going to take you through the basics of the design techniques for these three things, just as a taste for how 12D does these. Nothing that I do today can detract from the great work that Owen Thornton has done in 6 webinars that he's given and that are available via the 12D website. For detailed information about how to do stormwater drainage particularly, don't hesitate to go to the 12D site and search for Owen's work. We're going to start today by looking at gravity drainage for a stormwater drainage system. On the right-hand side of my screen here, I've got the layout of a little land subdivision. The low part of the project is down here to the south. Flow down this road is from the northwest down to the south, and we have a little cul-de-sac that flows down this way. Now, gravity drainage relies on us putting together a stormwater drainage network once we've figured out where the inlets are and how a pipe network is going to go together. So I've done that, and I want to show you where we're starting with. We'll go for SW here, and the location of my inlets are my inlet locations here, and this is where I think we need to have inlets. I have 2 at the sag points at the bottom of the cul-de-sac. I have one just before this curb return for water flowing down this gutter. There's one on the southern side of the road. This is to control the width of flow in the gutter. There's another one here again to control width of flow. 2 at the sag point at the bottom of the hill. There's the outlet for the system. Okay. We're going to put in one junction pit for this network. It's going to sit there, and these inlets are going to connect to this junction and carry on to the east. And we'll have a network that looks something like this when we're done. Okay. So this is my plan, is to put this together in a series of stormwater drainage lines. Before we kick off, before we create the lines, we need to tell 12D what's going to be created, what type of node, what type of inlet, and what type of link, what type of pipe. And we do this off the water menu, off the water string, and off the water string defaults. Here we tell 12D the finished surface tin, and this Super FS is a combination of the road design surface and the existing survey surface and any lot regrading that's occurred. The nodes that we're putting in, this road pit, they have a preset size, but if we were choosing a node that didn't have a size, then the default node size would be 1.1 diameter circular node, circular pit. We have a drop of 20 mil through the node, and the node name will be MH. On the links are all going to be 375 mil diameter, a minimum grade of 1 in 100, that's 1%, minimum cover of 0.45, and the type of line is going to be an RCP. Now, I don't like that 0.45. I'm going to change that to a 0.65 for RCP pipes. And we set that and finish. So everything that we create next is going to have those characteristics. To create the lines, we go to water, we go to water string, we come down to create, and we create. Okay. My first line is going to be line 1, and it's going into a layer, a model called SW network. And I'm going to create many of them, so I'm going to tick on the many strings tick box. I have my finished surface tin here, and I'm nominating my natural surface tin as my survey. Now, the flow direction here is set to be the same as the string direction. That is, flow starts at the uphill end and continues down to the downhill, to the low end. Change 0 for the link needs to be up here at the high end of the project, and the link's going to run down this way, and water's going to flow in the same direction as the string. I'll show you that, and if that's not the standard that you work to, I'll show you how you can use the opposite, which is opposite to flow direction. But to start with, we'll go create, and we'll create line 1 using edits, add append node. Now, for these nodes, I'm going to place them on the invert of the gutter. And that's not the invert, that's my superstring, that's my locator. So is that. That's the back of curb. I don't want my node there. That's the top of curb. There's the invert there. Enter locks that in. Okay, I'm going to move in here and do this, exactly the same thing for the next node. That's the footpath, not even close. Back of curb, top of curb, invert, lock it in. Okay, come across to the junction pit here, and I'm going to snap roughly in the center of that junction pit, and then move down the line. And once again, I'm looking for the invert of the gutter. Back no, top no, invert yes. We'll have another one here on the invert. Nice shot. Across the road. And we'll run that out to the outfall here. Okay. Now once we finish the drafting, we press escape, and that finishes the addition of the nodes. Now I've been fairly laissez-faire about the location of the nodes. I've tried to get them on the invert. I think I've been successful, but I haven't really worried too much about exactly where they sit. And there are some great tools for positioning them accurately. And there's also very, very easy to move them around. If I did want to move one, I could come into edits. I could come here, I could choose move. I could pick up the node that I wanted to move, accept that, and I could put it into a new location. All right. Now I don't want to do that. I'm going to press escape. That'll get me back to locating that on the invert of the gutter. Okay. Now I've completed this line, so I'm going to save and finish with the editor. And then we'll take a look at the long section of this line just to see what we've got here. Hit that wave button, come in here and choose that drainage line. And here's a long section of my stormwater drainage line. Let's wind that up to 10 times. Here's a long section of my stormwater drainage line. And as you can see, water flows from the low chainage end, from chainage 0, water flows downhill towards the high chainage end. Let's take a look at what that looks like in a long section plot, because this is where it becomes important which way around we draft them. Let's do a drainage sewer long section plot. The key to plotting inside 12D is to use a plot parameter file, and there are some great PPFs, great plot parameter files in the library. The one I'm going to use is the drainage long section PWA3. I'm going to select that, read it in, then choose the view that contains the data to plot, which is my LS view. See, it says section LS down here. Once I've chosen that LS view, it loads up the model of strings that I want to plot, which is my SW network. Once I've done that, I'm going to give the whole thing a new name, type in SW network, and I'm going to write it. That writes it back into the project area. So it started life in the 12D model library, but now it's part of your project. It's written in there. By default, it wants to plot to a model. Now, I don't want that. I'd like a PDF file. So I'm going to go for my PDF. I'm going to go for a half scale, 50% black. It's going to create a PDF file called plot-ut-ls-sw, and that's come from the plot parameter file that we loaded. It's going to add a number to it at the end. So we're going to end up with a PDF file that starts off plot-ut-ls-sw. We get that when we press plot. Takes just a moment to create the plot, and that's what it looks like. Here's my line 1, and as you can see, all of the nodes are named MH. We've got a graph here showing the line running downhill. We've got chainage 0 at the left-hand end, increasing chainages along the line. Now, if that's the standard that you use for long section plots for stormwater drainage, happy days, we could carry on. If it's not, if you like to see chainage 0 at the low end and the pipe running uphill, then we need to reverse the lines. So let's do that. It's very straightforward to reverse the lines. We go into strings, we go to strings edit, and we go reverse. We choose that line, middle click to lock it in, and now it's been reversed. Chainage 0 is at the left-hand end, but it's now the outfall. And just to see how that looks, let's hit that wave button again. We'll do our drainage sewer plot. We'll choose our SW network, we'll read it, and we'll plot it. The beauty of setting up the plot parameter file in this way is that it's so very, very easy to recreate your long section plots. Except that this one's plotting to a model, and I don't want that. I want it to a PDF. Half scale, 50% black, and let's just write that change. And then plot that. And here's the same drainage line, exactly the same design, except that this time chainage 0 is at the low end, and the line appears to be running uphill in the graph. And if that's the standard that you like to work to, we've nailed it. Okay, let's put that aside. Let's put aside the plotting. And let's create the other 2 lines. Now I've closed the string creation tool, so I'll need to get it back again. It's here under water, water string, and down to create and create. I don't need to fill it out again. I can simply go same as, and I can pick this existing line, and it fills it out the same way as that line, except that we're not creating line 1, we're about to create line 2. Now this is set now for the flow direction to be opposite to the string direction, which means that I need to draft the string running uphill, starting at the low end and running up to the high end. Pretty straightforward to do that. We'll go tick on the box that says many strings. We'll go create and edits, add or append. 12D pops up and offers me the chance to change what I'm creating, but I won't bother with that at the moment. I'll simply put a new node in here on top of that junction pit and draft it up to the inlet, which is up here on the curb. And once again, I'm shooting for the invert of the gutter. There it is there. Escape to finish that, and then save and finish to finish that line. We've got the many strings ticked, so we simply go back to line number 3 here. We go create, edits, add append. Here's my node. Once again, we'll connect to the junction pit, lock that in, and across the street, and we're looking for the invert of the gutter. There it is there. Escape to finish, save and finish here. I'm done creating water strings, so we'll finish that water string creation and refresh the screen. We'll add our stormwater drainage network onto this perspective view, SW network, looking good. And take a look at what it looks like in the long section. Here's line 1, the next line was line 2, there's line 2, and there's line 3. Fantastic. Now, so far all the work we've done has been in the plan view. We've created the thing in plan, and we've used a string editor. And that's pretty much the workflow, is to use a string editor in plan to create the layout of pits and pipes, layout of nodes and links. Once we've done that, we use the water network editor. It's found here under water, water string, network editor. Okay. And we pick edit. We can choose any one of the nodes or links, doesn't matter. They are all part of the same network. And I'm going to do a couple of things. Firstly, I'm going to regrade the pipes. Thank you very much. Secondly, I'm going to set node details. And that sets the inverts. It sets the floor of all of the pits to be a sensible position. I'm going to come across to my junction pit here. Now, at the moment, it's set up to be a road pit, which has an inlet. But I'm going to change it from a road pit to being an MH. And it says here that the size is different to what's in the database of pits and pipes. I'll say yes, we'll update that. And that, when I apply it, that changes it into a circular pit. Now I'm going to take off the preliminary drafting models that I added on here, my outlets, my network locations. And we can see our network of nodes and links draining from the northwestern end of the project down through the project and with an outfall to the south. Now at present, all of the nodes are named MH. We could quite easily change the names of these links. We could call this one 1-3 because it's the third line in the link. We could go to the next line and call it 1-4 and so on. But that's pretty tedious doing it by hand, when 12D has a great tool to set the node names automatically based on the string name, which is 1, 2, 3, with a sequential pit number. And it takes about as much time as that to do, and each of the nodes has a unique name now. Now, I'm going to be a little bit artistic here. I'm going to go to the outfall here, and I don't want it to be named 1-1, and I don't want it to be a road pit either. So I'm going to change it from being a road pit to being a headwall out, and I'm going to change its name to HW-1 and lock the node name and apply that. And you can see that we've got headwall 1, and then we've got node 1, 2, and 1, 3. Well, I'd like that to be 1, 1, and 1, 2, and so on. So I'd like to renumber. Set node names again, run that again, and now we've got headwall 1, 1, 1, 1, 2, 1, 3, 1, 4, 1, 5, and so on up through the network. There are a couple of nuances to this. If you happen to be working in the UK, you wouldn't want this 1, 1, 1, 2 nonsense. You'd just want every node to have a number. So you'd choose here and you just choose sequential numbering and you'd run it again, and then each node would have a unique number. That's not how I like to do it. Let's flip this back to string name followed by pit number and run it again. Fantastic. Back to the editor. Well, we've made a few changes to our network since I last did a long section plot. So let me go back and we'll create the long section plots again. Let me finish here. Back into the print button here on the long section, drainage sewer long section plot. Once again, calling my SW network drain PPF, reading it in. It's creating a PDF file, so we'll just hit the button that says plot. And in the fullness of time, we have a PDF of our long sections. And that's looking pretty good. We've got our node, our structure names across the top here, the type of structure, a graph showing the layout of the network, some information here about the size and type of pipes and grades and so on. We have some blanks where we've got the velocity, the normal depth and so on. The hydraulic analysis hasn't been done yet, so these are still blank. We've got the water surface, that's 0. We've got the finished surface and existing, the depth, the invert level, and the chainage. So looking pretty good. 1 or 2 things still missing, still waiting for our analysis. As you can see, it's pretty straightforward to plot that directly from 12D out to a PDF file. If you choose to, you can send it out to your favorite CAD package. Now in this case, I'm going to write out a DWG file, DWG sectional plot. And once again, the DWG file is going to be plot UTLSSW dash and then a number. All right. We hit plot. It takes just a moment to create the long section in DWG format, and it'll appear in the working folder, which we get access to from this button. Here's my working folder. Here's my DWG file. Open that in my favorite CAD editor. BricsCAD, have to be a winner. And you can see that we've got the same information here as we had in the PDF file, except that this is in CAD. The DWG file has been written into a drawing template, a DWT. So here under the layers, we've got a stack of layers that aren't being used. Let me just purge those. These are the layers that are being used in CAD. And these are the layers that are used for each of the different elements in the plot. All of the elements are set to be color by layer, and it's been sensibly split up into different layers. Okay. Now, it's been plotted with a 12D title sheet, as you can see. If you choose to, you can go back to 12D, you can turn off the title sheet, and you could cut this into your own title sheet. Moving along to the next of the 3 waters that 12D defines, which is foul sewer, we'll take a look at a gravity drainage system, which is our sewer system. We have a wet well at the low point in the project here, and a system of lines that run down to that wet well. These lines have been graded, grade from the downstream end at the minimum grade of 1 in 66. So you can see that the lines are 2-3 meters deep here. As we run up the line, it stays fairly deep. And this is deliberate. This is so that we can connect our houses, our properties into this line, and the line will be deep enough. The deal with sewer is that it's one of the very first things that are built on the project. It may be built after the lots are regraded, and it may even go in before the regrading. So what we need to do is we need to make sure that it's deep enough. And we have some tools that allow us to calculate the required depth just to make sure that the thing is deep enough. There are 2 things that work in tandem. One is a thing called a property control, where the internal line inside the property controls the depth of the trunk sewer. The trunk sewer has to be deep enough for the internal property line to drain into the trunk sewer. The second thing is the house connection, which is the way or the method of connecting the line internal to the property, connecting it to the trunk sewer. And I'll show you both of those. We're going to take a look at draining these 2 properties here, these 2 proposed houses. They are shown here in the perspective view. And we're hoping that something impressive like this will be built. And we need to figure out how deep this trunk sewer needs to be in order to pick up the foul water from these 2 properties. How deep this line here needs to be in order for these 2 properties to drain. The first thing I'm going to show you is the property control for this property here. We're going to go into our water, we're going to go water string, and we're going to go a string editor. Pick and edit that string there. And here on my editor, down here under controls, I'm going to add a property control. But before I do that, I'm going into water. I'm going into water string and take a look at the defaults here and see what 12D is going to add. Hidden away here are the defaults for property controls. And this says that we're going to put in a 100 millimeter pipe. It's going to be graded at 1 in 60 with a cover of 450, cyan in color, and its name is going to be lot. And when the time comes, we'll make it lot something. We'll set those and finish, and we'll create this property control. So let me go here, let me go controls, let me go and add, and I'm going to add a control to this line here. I'm going to add it roughly at this location here. And we're going to draft the line in roughly the position that we might have to put the drainage line in order to drain up to the corner of the property and to drain a bathroom or toilet that was in this, or even maybe the kitchen that was in this back corner of the property. This is lot 45. And this cyan line is the property control for lot 45. And it's just a proposed arrangement. We could put a number of other ones in, but you can see here in the long section that the invert level of that property control is coming in just a little bit above the level of the trunk sewer. This tells us that the trunk sewer is deep enough. Now, what I've done is a fairly onerous condition. The land all falls to the south here. So I've gone for a low point on the land and I'm grading backwards toward the main. If we want to see the long section of this line I've created, we do a right click on here. We choose one substring. The property control is a substring of the trunk line. We choose the substring and lock it in. And you can see the ground here running in the opposite direction to the drainage line. We've got the drainage line particularly deep because of the topography that we've chosen. And down here in the bottom left corner is our trunk line, and that's just deep enough to pick up our property control. Now, in reality, there'd be a good case to put the property control out towards this position on the trunk line. And certainly that would be an option that you'd look at if you were designing this for real. And you may be able to lift this trunk line, not have it quite as deep. At the moment, if we take a look at the trunk line, you can see that it's coming in a good 2.5 meters deep through here. And that's going to be expensive to build with shoring and so on. So that's our property control. It's a line that we draft inside the property, making a guess about what the plumber's going to need to do to put the internal drainage in. And we put that property control in an attempt to make sure that our trunk line is deep enough. We can do the same thing here. We'll put a control in here. We'll add a control for this property. I'm going to put it in, connected in about here. Put a simple control in here into a kitchen area that we're going to place there. Escape to finish that drafting. And when we refresh this view, this control has no trouble in the world. It's running in the same direction as the land, and it's very, very high. And this will be lot 46. Now those controls, as I say, they make sure that the trunk line is deep enough to pick up the internal plumbing inside the lot. We then connect the property to the sewer using a house connection. And there are two ways of defining house connections, and I'll show you them both. We'll go into house connections here and we'll create from controls. Okay, we put a factor of safety in and we go create. And there's a vertical pipe that links the house connection, that links the property control to the trunk sewer. That's pretty straightforward. We can finish that. Now, if we didn't want to have that if we didn't want to have that very simplistic arrangement, if we wanted to have some more control about what was being built here, and if we definitely wanted to build something on the trunk sewer that the plumber could use when the time came to build these houses, we could manually put in the house connections. So I'm going to go house connections here and I'm going to delete them all. I'm going to go controls here and I'm going to delete them all. And we're simply going to put in some stubs on this line that the plumber will use when the time comes to do the internal plumbing. We'll come to our house connections and I'm going to create. Hit the button that says create and we'll select a drainage line. We'll select this line here. And 12D prompts us to choose the property boundary that this line is going to be related to. So I'm going to choose one end of the property boundary. I'm going to choose the other end of the property boundary. And 12D pops up and says that along that line is 0.33 of 1% crosswall. So it's pretty much flat. It's suggesting that we put the house connection in at the midpoint on the line, which is at that change there on that line about there. But I'm going to say no. What I want to do is to start there. I'm going to come 2 meters into the property and put my house connection in that location. That's going to be at a slightly deeper end of this pipe between S3B and S3A. So backspace over the 12, give it 2 meters and enter. Here's my little house connection, this little stub just here. It shows it to us in the long section view. There's the trunk line with a little house connection coming out. And if we take a look back at the long section of our trunk line, there's our house connection sitting, and it's sitting a meter. The top of the house connection is a meter below the surface. Okay. Now there are one or two things to adjust here. The lot name is lot number. The lot name is lot 54. We are using a PVC pipe. We're not using vitreous clay, so there's no bush required. And at the moment, it's an OB type connection, and we better put it on the left side to service this northern of the two houses. Okay. Connection level 97.97, roughly 3 meters, is that roughly 30 meters is that point there. Okay. Now, what the heck's going on here becomes a heck of a lot more clear if we take a look at it in our perspective view. So let's just take a look at, let's zoom in on the perspective. And we've got a house connection being created here. So this joint will be added, this connection will be added when the trunk line is built, with the intention of marking it on the plans that the plumber can dig down and find it and connect the property into the trunk line when the time comes to build the property. We have a number of different house connection types here. The default that came up here was the OB type, but we can put a type A in. And that gives us a far different arrangement. That puts it closer to the surface and gives the plumber less work to do. We can put in a type B, which would be my pick, where we simply have a riser coming off the joint here. As you can see. Now if the plumber wanted to come in at the top of there, that's fine. If they wanted to come in deeper, cut off that riser and join in partway down, that would be fine as well. But the infrastructure that's left when the sewer is built is this riser coming up to 1 meter below the surface. A couple of other options here. We've got our type C, which is not as expensive. A special. Okay, which again is slightly different. And my favorite of all, which is the special jump up, which is quite an amazing set of fittings. Okay, my pick would be type B, where we just have a riser coming up. But depending on your authority, depending on what you're required to build, you specify that. Now we'll do exactly the same thing for the next property. I'm coming back to my plan view. I'll finish this one, finish that. Coming back to my plan view, this time we'll go into house connections. We'll go create, choose that line there, and choose the start and end of the frontage. And once again, we've got a low crossfall, 12 is suggesting 12 meters. I'm going to put this in at 20. And you can see where it's sitting just here. Bush type is no bush. It's a PVC pipe. And we're going to give it a type A connection. Okay. The 30.22 is 1 meter below the surface. We'll try that. And once again, take a look at our perspective view. You can see the second house connection's gone in at the other end, near the other end of the property. You can see the two of them there. They don't appear to be below the ground in this perspective view until we spin around and take a look below the ground. And in fact, you can see that they are. They're finishing 1 meter below the surface, ready for the plumber to do the internal plumbing work. So the design process for hooking up these houses into the sewer system is pretty straightforward. You get to do it for the entire subdivision. When you've done it, you'll have flow in the pipes and you'll have flow flowing through the system, and it'll end up down at the southern end of the project here in this wet well. And the wet well is what I'd like to take a look at now, because I've designed a rising main to take water from the wet well and deliver it up into a receiving sewer at the western side of the job here. We have a collecting manhole and a discharge. Now, in order to model this, without all the houses being modeled and without modeling EPs or ETs, what I've done is I've assigned a small flow to each of these nodes. We can't assign a flow into the house connection. flow has to be assigned at a node. So we could model it by taking the flow from these two houses and assigning it at S3B, or we could take the flow from these two properties and assign it at S3A. Either way, we're going to end up with the flow from the properties flowing through the system and ending up in the wet well. Now what I've done is I've gone through the network in my network editor, and I've assigned a small flow to each of these nodes. If I go to the link here, and here's the flow, it's 1.5 liters a second that's being modeled as arriving at that node. If I click down to the next one, I've got 2 liters a second being modeled at that node. So I've got flow arriving at each of the nodes, and it ends up in the wet well here. Okay. If we come and take a look at the wet well, okay, and the node on the wet well, I've designed a 5-meter diameter wet well, so it's a fairly large, fairly large. It's a large structure. The floor of the wet well is in at RL24. The cover is at RL29. So it's a deep wet well. It's nearly 5 meters deep. Alrighty. Let me rearrange the view so that we can see what's going on here. We don't need the perspective anymore. Let's take a look at my plan in top right, my long section, and we'll have the network editor here on the left. Right. Looking at our wet well, it's a 5-meter diameter node. You can see from the RL24 there up to RL29, it's 5 meters deep, and you can just make out the incoming sewer coming in at RL26. Quite arbitrary. We could have that coming in at any level we liked. Most of the links in the network are conduits, but if I come to the link tab here, this is a 150 link. It's the link type. Its type is pump, and it's not a conduit. Most of the links in the network are conduits, but this is a flow head dynamic. It's flow head dynamic. In our hydro file, we have a number of different pumps defined, and I've chosen a pump from the hydro file. The pump kicks in. The pump starts when wastewater in the wet well gets to RL28. That's to about this level here, not quite to the top, about 1 meter from the top, but that's when the pump kicks in. It stops when the waste in the wet well gets down to 24.6. So it's roughly down the bottom here, about 600 millimeters deep. Okay. The initial state is off, so the wet well will fill up before the pump kicks in and starts to pump. Now the next pipe in the line, that again is not a conduit. It's a special type of pipe called a rising main. Its roughness is defined by Hayes and Williams, and I've punched in a roughness there of 130. This is a 150 mil diameter PVC pipe. Okay. As I click through the network, you'll see that there are 1 or 2 nodes in here, and these are to give us changes of vertical direction. You can see that it's straight up all the way up the road here. A change of vertical direction, or as we come to the top of the hill, we have a change in horizontal direction as the fluid enters the collecting manhole. And from here on in, it's flowing under gravity, and it's a 225 pipe that's carrying the water down to wherever it gets carried to. Right, well, we're going to use the dynamic drainage engine to analyze the response of this pump to the flow that's arriving at the wet well. Right, we're going to the analysis. Okay, I've got my hydro file here that's got my pumps in it. This is where my pumps are defined, and I'm simply going to push the run button. Then one event to be analyzed, and it only takes a few seconds. Thank you, and back to the editor, and we'll take a look at the results of that analysis. Okay, I'm going to flick back. I'm going to come back to my rising main, because it's the rising main. It's the flow in this pumped section that I'm most interested in. We're going to take a look at the results here, and we're going to take a look to start with at a dynamic section. So what happens when the analysis starts is that foul water starts to flow through the network and arrives in the wet well. Right? It'll fill the wet well until it gets to this green spot here, which is the RL28, and then the pump will kick in and pump the water away. And this is what happens when you press play. You can see the fluid here in the wet well is rising. Okay, we started empty, so we're starting to fill that wet well. And When the fluid gets to the green spot there, or when it gets to RL28, the pump kicks in, it lifts the water, it pumps the fluid up into the receiving waters. What you can see is the hydraulic grade line, and the pump will empty the wet well. It'll take a few seconds to do that. These vertical risers here aren't actually to be built, but what I've needed to do is to lift the grate level up to RL52 so that the water doesn't exit the node and into the overland flow system. The grate level in 12D indicates the maximum pressure that we can put onto a node. Now I have a one-way valve here at the end of the rising main, so the hydraulic grade line only ever drops as far as the invert of the receiving manhole. The wet well fills again. Now what I'd like to point out to you is that when the wet well is full, when the fluid is up to this green line here, up to RL28, that the pump needs to lift the fluid up to the level of the receiving manhole, which is up here at around about 34. So it has to lift it about 6 meters. When the wet well gets empty, when it gets down to less than 25, about 25.6, the pump kicks in, it has to lift it from 25.6 all the way up to elevation 34, which is closer to 8 or 9 meters that it has to lift it. Now the characteristics of the pump are that the greater the head it has to push against, the higher it has to lift the fluid, the less it can pump. And we'll see that when we take a look at the flow graph, because the next graph I want to take a look at is the flow through the pump. And what you can see here is that as the time starts, the wet well starts empty, and it takes an hour for the wet well to fill to the stage where the pump kicks in. Now when the pump first kicks in, it lifts the water and it's pumping at almost 140 litres a second. But that's because it doesn't have a very great difference between the water fluid level in the wet well and the level of the receiving main, level of the receiving manhole to pump that water. But then as the wet well empties, the pump has to work harder and harder to get the fluid up to the receiving manhole, and the flow rate decreases as the wet well gets emptier and emptier, until we get to a stage where at an hour and a half, the wet well is empty, the pump kicks off, flow goes down to 0, and it stays at 0 for almost an hour, about 50 minutes. And then when the wet well's full again, it kicks in and it's pumping again at almost 140 litres a second. So this is the characteristic, the flow characteristics through the pump, and we would see similar flow through all of the links in the rising main. Now, what happens if we change the node size? If we come back here and make the node smaller, I'll make the node a 2 meter size wet well instead of 5 meter. Apply that. What's going to happen is it's going to fill up a lot more quickly because it doesn't have as much storage. It's also going to empty a lot more quickly because there's not as much for the pump to pump out. The start and stop levels are the same, so the pump cycle will be a lot faster. We run the analysis there. Again, it only takes a few seconds. Okay, finish that. Back to the editor. And let's take a look at our results, and we'll take a look once again at our dynamic section. So this is exactly the same rising main, exactly the same incoming flow, but with a much smaller wet well. And when we play that, it fills a whole lot quicker. And when the pump kicks in, around about now, it empties very, very quickly and fills again and empties. So that cycle time is a lot shorter. The pump's going to go through a lot more starts and stops. And if we take a look at our flow, we can make an assessment of how often the pump kicks on and off. You can see that to start with, the flow arrives, and once again the pump kicks in and runs for a while and then comes out again. So let's take a look at the timing here. To fill this wet well, when it was a 5 meter diameter, it took almost an hour. When it's a 2 meter diameter, it takes 13 minutes. It takes a little under 2 minutes to empty the wet well, and then it starts to fill again. So the pump's going to be cycling 6 or 7 times an hour rather than once an hour that it was cycling with a 5 meter wet well. Now, to finish off today, I'd like to show you what we can do with a water supply network where we can use the same dynamic analysis engine to analyze flow through a network of pipes that are provided for water supply. Down here at the bottom of the network editor, we have a number of options for our hydraulic analysis, and this is our water supply. When we choose water supply, the network editor changes slightly, and here under nodes, we have a water supply node, and we can set a node to be one of three types, either a junction, a tank, or a reservoir. If we make it a junction, we can supply a demand pattern. Okay. We can also define tanks, and we can define a rating curve for a tank at a particular node. For our links, or our water supply, we can define a link to run in a number of different ways, either as a pipe, which is going to be most of them, or as a pump, which is going to be a few of them, and we're going to have a rating curve for our pump, or as a valve. So with those controls over the nodes and links, we can apply a demand, we can provide a reservoir, we can provide a tank, and when we press the analysis button, it'll give us a dynamic analysis of all the nodes and links in the network using the same engine that we use for our dynamic drainage and the same engine that we just saw for the rising main for the sewer system. If what you've seen today would be useful to you, if you'd like to know more, please don't hesitate to reach out to me. I'm at exds.com.au, or you can email sales@12d.com. Thanks very much.